looking at section 9.2, simplifying radicals. We have a couple of goals: using properties of radicals to simplify radicals and using quadratic equations to model simple real-life problems. Beginning on page 511 in the textbook. First thing we have is a definition of simplest form. Basically what this is, it's a checklist for you. It's 3 questions that you have to ask yourself every time you see a radical come up, every time you have a radical expression. The first one is, there are no perfect squares that are factors other than 1. So that's your first checkpoint, no perfect squares. Got to ask yourself that question. Are there any perfect squares? I guess would be a better way to say that. Any perfect squares. Second question, second one is, no fractions in the radicand. Any fractions? And go back to yesterday. Remember, the radicand is what's underneath the radical symbol. So if you have a radical symbol with a fraction in it, such as this, that's not considered simplified. You have to do something with that. The third question is, are there any radicals in the denominator? Radicals at the bottom. I'm sorry, fractions. No radicals, okay. Radicals at the bottom. I'm trying to think one thing and write the other. Radicals at the bottom. If you have something that looks like this, 1 over the square root of 2, this is not considered simplified. You cannot have that radical at the bottom. In order to undo a radical at the bottom like that, you do what's known as rationalize the denominator. Make sure y'all write this in, everybody. I don't believe it's on your paper. To rationalize the denominator, rationalizing. If you have this example, 1 over the square root of 2, you cannot have a radical at the bottom of your fraction. In order for you to undo that, we need to multiply this by something that's going to take that away. If we put the number 2 over the number 2, that simplifies to 1. If we put the number 22 over 22, that still simplifies to 1. If we put 222 over 222, it doesn't matter what we put over itself, it's always going to simplify to 1. If we multiply anything by the number 1, it doesn't change it. But what it's going to do is it's going to allow us to make this into a form that's acceptable. So the easiest way to do it is to look and see what is the radical at the bottom of the fraction. It's the square root of 2. So multiply this problem by the square root of 2 over the square root of 2. Again, just like all of these 3 here, the square root of 2 over the square root of 2 simplifies to the number 1. And anytime you multiply something by 1, it just keeps it whatever it is. It's just going to make the form change for us. So when we multiply straight across with this, 1 times the square root of 2 will simply be the square root of 2. And then we have the square root of 2 times the square root of 2. This is the same radical. Anytime you have the same radical, the shortcut is to just pull it from underneath the radical symbol and call it 2. But if you can't see that just yet, multiply the square root of 2 times the square root of 2, and you'll get the square root of 4. We know that that is a perfect square. The square root of 4 is 2. So you're left with the square root of 2 over 2 in this sense, which is considered a simplified radical. Here's properties of radicals. The product property says that the square root of a product equals the product of the square roots of the factors. In this example, the square root of AB is equal to the square root of A times the square root of B. This doesn't really look like this most of the time. It'll be like the square root of 36. Oh, not 36, that's a perfect one. It'll be like the square root of 12. Obviously, that's not a number like the square root of AB. This is one value we're looking at, but it's not a perfect square. You can separate it into the perfect square 4 times the non-perfect square 3. And then 4 will separate and give you the value 2 times the square root of 3. The quotient property says that the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. The easiest way to do this is it separates. Notice the square root of A over B is the same thing as the square root of A over the square root of b. Just separate it is all you have to do for that one. Example number 1 is simplifying the expression of square root of 27. You can use the product property by removing the perfect squares. Remember, your perfect squares: 1 times 1, 2 times 2, 3 times 3, 4 times 4. Get used to these numbers. You're going to use them plenty. 5 times 5, 6 times 6. Write them out if you have to at the beginning of assignment where you can keep referring to them. 7 times 7, 8 times 8. Use those numbers. You can use them up an infinite amount. You want to look for one of those values that is a factor of 27. Start at the beginning. 1 is, but that's not going to change anything. You can't multiply 4 times anything and get 27. You can multiply the number 9 by something and get 27, but let's keep going and see. 16 by something doesn't give you 27, and then 25 we start getting where it's getting too big. So 9 is the only number that you can multiply by something and get 27. So you take the value, the square root of 27, and you separate it into, always put the perfect square first. It'll make your coefficients line up a whole lot easier. The square root of 9 times the square root of 3. Then we could simplify that. 9 times 3 like this. The product property says you can separate them. I go ahead and separate them on the first step because I've never been proven wrong doing that before. And then the square root of 9 is simply the number 3. Notice here, it comes out of the radical symbol. It just gives you the value 3 times the square root of 3. Then you have to ask yourself the question once you get here. We had 3 questions we had to ask. The first one, is there a perfect square that's a factor of the square root of 3? No. None of these values, none of these perfect squares can you multiply by and get the number 3 other than 1. There's no radical in the denominator, and there's no fraction underneath the radical. So that is considered a simplified answer. Here's example number 2, the square root of 5 over 16. Notice this is not considered simplified because it is in a fraction. It can't be, a fraction can't be under the radical. So what you want to do is you want to separate. This means the same thing as the square root of 5 over the square root of 16. All you do is separate them. There's no perfect square that's a factor of 5, but the square root of 16 is the number 4. So the square root of 5 over 4. You get yourself back to this question. Do we have any perfect squares that's a factor of the radical? Nothing we can multiply. Remember, your perfect squares: 1 times 1, 2 times 2, 3 times 3, so on and so forth. None of those numbers multiply by something give you 5. There's no fraction underneath the radical symbol. This is not, and this kind of looks like a fraction under the radical symbol, but notice it's not. The only thing that's actually under this radical symbol is the number 5. 4 is below everything. And then the last one, there's no radical in the denominator itself. B says the square root of 48 over 75. First thing you want to do, separate them into the square root of 48 over the square root of 75. Now, the reason they used 3 times 16 and 3 times 25, beyond the fact that 16 is a perfect square of 48 and 25 is a perfect square of 75, the reason they use these two is because you can cancel out the same numbers over each other, just like we did in the Bell work. 3 over 3 will cancel each other out and simply leave you with the square root of 16 over the square root of 25, which you can separate to look like this: the square root of 16 over the square root of 25. Remember, that means what times itself is 16, you get the number 4, and what times itself is 25, you get the number 5, 4/5. And that is considered simplified. There are no numbers that are factors of those. Then we have a checkpoint problem. Obviously, the square root of 12 is not a perfect square, but you want to use your perfect squares. Remember, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Again, you'll get way more familiar with these numbers as you use them. 7 times 7, 8 times 8, 9 times 9. Which one of those is a factor of the number 12? 4 is the only one, so separate it and put the perfect square 4 first. Then you have to ask yourself, what do I need to multiply 4 by to get the number 12? The square root of 3. The square root of 4 means what times itself is 4, and that simply is 2. Bring down your square root of 3. There's no factor that is a square root. There's no perfect square in 3. It's not in the bottom of the or it's not in the bottom of the fraction or denominator, and there's no fraction under the radical. So that's your simplified answer, 2 times the square root of 3. The next one says the square root of 63. Again, check your perfect square values. Which one of those is a factor of the number 63? The only one that comes up. And even if you use the wrong one the first time, you'll just take one extra step to simplify. So don't be scared to use the wrong one if it's a factor. The square root of 9 multiplies by the square root of 7. The square root of 9 means what times itself is 9. So 3 times the square root of 7. And there's no perfect square that's a factor of 7. And then the last one is the square root of 13 over the square root of 36. Square root of 13 over the square root of 36. There's no perfect square that's a factor in 13, so that one's going to stay as the square root of 13. The square root of 36 means what times itself gives you 36, and that number is 6. Then you have to ask yourself, at this point, you have to ask the 3 questions. Is there a perfect square that's a factor of that radical 13? No. Is there a fraction underneath that radical symbol? No. And is there a radical symbol at the bottom of the fraction or in the denominator? No. So this is a simplified answer. As hard as that is to believe, that's your simplified answer. Number 4 says the square root of 48 over the square root of 81. Separate it into the square root of 48 over the square root of 81. What's a factor? Remember, your perfect square is 1 times 1, 2 times 2, 3 times 3, all of those numbers. 16 is the number that comes up first to me. The square root of 16 times 3 over the square root of 81 means what times itself is 81, which is 9. Notice we got rid of the radical symbol for that one. This means the square root of 16 times the square root of 3 over that same 9. You can't forget to put that 9 there. The square root of 16 means what times itself is 16. So you have the number 4 times the square root of 3 over 9. At this point, ask yourself, is there a perfect square that's a factor of 3? No. Is there a radical at the bottom or in the denominator? No. Or is there a fraction in the problem? No. There's one other question you have to ask yourself that's not dealing with perfect squares, but it is dealing with simplifying fractions. Had that been instead of a 9 at the bottom, it was an 8, then you would simplify 4 over 8 and cross them out and put 1 over 2. But this is your simplified answer. 4 times the square root of 3 over 9. For number 5, it says the square root of 54 over 3. Perfect square that's a factor of 54 is the square root of 9 times the square root of 6 over 3. Notice, don't add any symbols that aren't already there. Don't accidentally put the square root of 3 at the bottom because it's just 3. The square root of 9 means what times itself is 9. That is the number 3 times the square root of 6 over 3. And this goes into that last step I told you from number 4. This says 3 divided by 3. Notice they're the same number. We can cross those two out and simply call it the square root of 6. Ask yourself the last question, the last 3 questions. Is there a factor that's a perfect square that's a factor of 6? No. Remember, your perfect squares are 1, 4, 9, 16, 25, and so forth. There's no fraction underneath the radical, and there's no radical in the denominator, square root of 6. Then the last one says the square root of 90 over 160. First thing you want to do, separate it into the square root of 90 over the square root of 160. Which one's a factor of 90? The square root of 9 times 10 over the square root, what's a factor of 160? 16 times 10. Again, just like the last one, we have times 10 for both of them. We can cross both of those out. That leaves you with the square root of 9 over the square root of 16. What times itself gives you 9? Number 3. And what times itself gives you 16? And number 4. Notice both of those came from outside the radical. 3/4 is simplified.